Let's have a look at question 2. So your dependent variable in question 2 is theta. The independent variable is alpha. If you cover up the derivative and you look at the rest of the equation, you have a mixture of dependent and independent. You have 1, 2, 3 terms, and in this case you can't change these to 2, so it's not going to be separable. Then we check to see if we have a linear differential equation, and you remember that linear means it is linear in your dependent variable, and that means that theta is to the power 1, which is exactly what we've got here. So this is a linear differential equation. So the first step with solving a linear differential equation is you want to get it into standard form. And your standard form looks like this. dy dx dy equals q. Right? So the first term in your standard form is the derivative on its own. The only thing in front of it must be a 1. So in this case here, you do not want to have that alpha there. So we're going to divide through by alpha. And we're going to have the alpha, theta over alpha plus alpha squared. Right? The next term in your standard form is where your dependent variable is linear. So we want to move this term to your left-hand side. Theta, the alpha is equal to alpha squared. Right? And you'll see now, in your standard form, the q, you remember, is made up of only your independent variable or constants, which is exactly what you've got here. The next step is to find your integrating factor. So f is equal to e integral of to alpha. Please remember that the sign is part of this value here. Right? That's a common mistake that students make. So that is going to be that, which is using your log laws, minus 1, which is 1 over alpha. Right? Once we've got the integrating factor, we can then substitute into this equation here. Theta f equals f times alpha squared. So we're going to get alpha squared d alpha, and we've got theta over alpha equals integral, which is just a half alpha squared plus c. And that is the solution to your differential equation. You don't have to simplify it any further. It depends, of course, on what is asked of you in the question.